Hi guys. Since doing this video, I've had quite a lot of comments asking how I made the buttons, and also some people are asking about the coding. I get quite a lot, to be fair. So what I thought I'd do is show you how easy it is to set up, and I've also found a program to allow me to do it nice and easy, which is Tinkercad. On here you can create circuits. You can also make 3D designs, which is what I mainly use it for, and it's also free to use. So we'll jump on here and show you how easy this is. So first things first, we'll get a breadboard, and you can place that wherever you like. We'll have an Ardunio because we're going to need that. So we'll chuck that just there, bring that up a little bit, and we're going to need some resistors and some buttons. So first of all, we'll start off with just one button, so we'll make it nice and simple. So we'll chuck the button in here. We're going to want a resistor, so we'll stick a resistor from positive on this side here to there, and we're also going to need to bias that resistor with a ground to obviously keep the voltage low. And then I can't remember how to do the wires. I think you just click actually. Yeah, what I'm going to do is tie it into here. So that's going to be our output wire, the green one, and then I'll send the output from here to, we'll go to analog 0. So that's the first connection. Then we're going to want a 5 volt. So we'll 5 volt this rail here, and we'll change that to a red. And then we're going to want a ground. So I'll bring that up, and obviously bring in the ground. So now we've got power to here and the button, but we also need to write a bit of code for the Arduino in order to see our results. So what I'm going to do is, we'll take that off, we'll jump on the code side. I don't like that, so we'll go down to text, continue. Right, we don't need this, so we'll get rid of that bit of code. We don't need that, so we'll get rid of that as well. In fact, I can edit that in a second. So what we'll do is first, we're going to need a global integer. So we'll do int, and we'll call it read. And also you need one of them at the end of it. We don't need a value in there because the value will be set when we're pressing the buttons. So obviously in the setup we've got the pin mode, which we need to change. We're using A0, so it'll be A0, and we want to change that to an input. I think it is an input by default, but it's not always the case. So we'll put input in there, and that's the pin mode. That's that setup. Also, we're going to be using the serial to read the information, so we need to add a serial. No, load up serial.begin. I'm trying to remember myself now. Serial.begin, we'll set that at 6900 because we don't need it doing anything major quick. And then we're going to come down to the void loop here. So the first thing we want to do is analog read. Oh. And we're going to be reading A0, and also we need to use our read function. So we'll say hold up, no, that's right, read. So read equals analog read, and then we need a serial.println, and in there we're going to print read. Okay, that's it. That's as simple as it is. So if we start the simulation, we should start getting something down on the... Oh, what have I missed? I might have done something wrong here. Oh, that's what. So that begin. I did it all wrong. There we go. Right. So try that again. Start simulation. That should work now, I think. There we are. Right, so serial monitor. So forget that first bit. So obviously you can see we're reading zeros. That might float, so you may need to use a capacitor to pull that down. But when we press this, we should get a result. And as you can see, we've got 511. These are just 1K. That's what they're set to by default. You can change them to whatever value you like. Obviously, if you want more buttons, I'd drop it down to homes and probably 500. But you can get quite a few buttons set up like that. So obviously there's the button. You click the button and we're getting 511. Now in order to use that bit there, the 511, all we need to do is in the loop, if we put if, oh, why aren't we typing? Oh, because we're running a simulation. Right, so try again. If so, in there we want if read and then equals 511. Obviously we wanted to do something, so we put that in these brackets. So we'll just have it say we'll use serial, so we'll do serial dot println, and we'll have it say, oh, we don't want it to have it say star. Two brackets, and we'll have it say easy. So if obviously if the serial read, the analog read, sorry, if the read value equals to 511, which is the value we've just gotten, because obviously we tested it, we want it to print out easy. Okay, so we'll start the simulation, and we'll press the button, and as you can see, you're still getting the 511 results because that's here. Obviously, if you wanted to remove the serial print for that, you'd simply just comment out that line or just totally remove it. And to comment it out, you'd just do that, 2 lines. And obviously if you run the simulation now, it'll just say easy as we hold the button, like so. So now if we want to add more buttons, very, very easy also. So we'll stop the simulation. We'll move this out of the way, and we'll come back to the resistors. So we'll continue with the 1K resistors, but the only difference this time is we're going to placing it in like so. So what I'll do is I'll do it here. So you can see, obviously we'll add a next button. So we'll drop the button in. Yeah, we'll drop the button in there. Now, in order to save resistors, what you can do, rather than adding another resistor here, is if you get a wire and bridge it from there to there, you'll still get the values, same values regardless. But obviously this resistor is going through that resistor, which is by basically making it like a 2K resistor, I think. I can't remember how they work in series and parallel. So now if we go back to the code and we start the simulation again, we're not going to get anything because I haven't wired it down here. So we'll just drop another wire from there into the positive rail, start the simulation. So obviously we've got the first one here, which is 511 easy, and if you see the next one, obviously we've got a lower value there, which means we can give that one a function. And as long as you do the analog read first and get the values, you can pretty much use these to your heart's content, and you can add as many as you like. So if we let's add a few more buttons. So we'll start the simulation, we'll move that out of the way, and we'll bring in another button. Let's see how many buttons we can get on here. I think that's about it, because this breadboard isn't big enough. I could use a bigger breadboard, but then I'd have to zoom out and you won't be able to see what's going off. So we'll do the same thing again, so we'll get some more resistors. We'll keep it at 1K for now, because we should have plenty. So what we'll do is we'll tap it from off of that one on the same line, and that will line us up then with this one here. So now obviously there's 3 resistors it has to go through for this button, which is going to drop it further. And then we'll get another one, and we'll do the same thing. We'll just keep pouring them across till everything's linked up, like so. And one more, So now all of these are chained up. Obviously we need to add some more bridges for these, so we'll wire them up. So we need to go from there to this pin, and we'll do the same on this one, and the same on that one. Oh, you stay in there, you get. Right, same again, and one more for this side. And everything should still work through. Obviously we're still going to need to connect this here. Obviously if you was doing this on like a perf board, obviously you wouldn't need all these connections because you'd just wire it all into the same track. So we'll stick that one in. Why is it being a beggar? Right, like so. So if we come back to our code now, obviously you see we haven't really changed anything, we've just changed our design of the board. So if we press the first one again, we get the 511. The second one we're getting 341. The next one we're getting 256. The next one we're getting 205. 171. 146. And 128. One thing also you could probably do on here is if obviously on an Arduino there's going to be a bit of noise, so them signals might be bouncing around. So what you could do is have a ground. Oh, don't stop simulation a second. Right, so if we have a ground and add it down here. Actually, I don't know if that's going to work like that. Let me get a capacitor. So we'll just close that a second. Is there any capacitors? We're using electrolytic as the most common. Should we add some? I was just thinking then, oh, that's just basic. So we'll go to all, see what we've got on here. There we are, polarized. Which side's where? Oh yeah, right. So, oh, that's not very. Yeah, I'll do it that way. So I drop that in like. Oh, it's not going to go, is it? Oh, that's not very good, is it really? Basically, what you'd be doing is, we can just drop it between the two. Oh, there we go. That'll work. So basically, we've got the negative on the negative side of the capacitor, and then the positive side. Let me just check that that's in. So if there's any noise now with that electrolytic in there, any noise that's on that line would have to pass through this capacitor. It shouldn't change your values. Your values still come out roughly the same. There might be a bit of drop, so they might alter slightly, but they should be the same. But all that's going to do is it's going to get rid of that ripple and that noise that's going through to the Arduino. So obviously you get a nice clean, results like this. Right, so if we want to add more functions to these buttons, obviously it's just the same thing. So if we do, let me get a reading again. So that one's 341, so we'll stop the simulation because otherwise it won't let me do anything. So if read, 341, then we'll have it do something. Let me just see if there's any LEDs. There should be LEDs on here. There we are, just a regular LED. Where can I plop it? Right, where's the negative leg on that? I'm not sure. What we'll do is we'll drop it in ground, and actually we can't really use 13. Or can we? Yeah, we can use 13. We'll use 13. Let's go back to the code. So we obviously need to add that in here. So be pin mode. Oh, lowercase. Pin mode, capital M. And we'll just put 13, which is our pin. We want that as an output. So that's that setup. And then in here we'll do digital. Oh, digital right. So if that's true, we want that obviously LED to turn on, so we'll set 13 high. So you can either do 13 and then high, capital, like so, or you could just do it as a 1, and obviously a 0 would be a low. But we'll just keep it simple. So there's your high. So we've got digital right, 13 high. But we also want to do it something else afterwards, just in case. So we want to add an outs. And then digital. Oh. No, hold up. Outs, digital right. $13 and low. Now the reason we want to do that is because where's the rest of that code gone? This is not very good, is it? This really? Can I make this bigger? Oh, there we go. All right, so that's set. We need to move this bracket here as well, because obviously we're adding a bit more function to it. I think. Hold up. No. Leave that in. Oh. I can't remember if that goes before or after the outs. It's not a good start, is it? Outs. And then that. There we go. That's right. Right, so if we start simulation now, the reason we've done that is that will turn the LED off when we let go of the button, hopefully. I'll come back to the code. I press the first. Actually, we need that up just for the just for that. So we'll just bring that across. Let's try and bring the LED back into view. There we go. So press the first one. Obviously, we get the message. Now that one should light up the LED, which it's just come on, as you can see. And when we let go, it turns out. Now if you wanted that to turn on but then turn off if you was to press a different button or press it again, you'd have to obviously write a little bit more code for that. But you can see that obviously because they're different values and you're reading these values, you're able to then control multiple buttons. And like I said, the list can go on. You can go as far as you want. You may need to change down on the resistors. That's the only difference. So if you change the main grounding one here, we'll change that to 500 and we'll drop it to ohms. Obviously you'll get different results coming out of here, and obviously your buttons ain't going to work anymore because that's 341 now, you see. And obviously before it was oh no, that's the wrong one. I need to up that one, sorry. That's my bad. Right, so we'll do 2K, sorry. It's because I'm on the ground rail. That's a 2K. Now that should up the resolution. See, now we're at 682, and our lowest one is 227. So there's ways you can, just by changing one resistor, and because obviously it's easier to change that one than it is to, you know, change all of those to a similar value. I mean, another way you could do it is obviously if you use like a lower value ones anyway, it's not going to give you much range in between each value. Obviously we've got 511 there on that one and 682 there, so our 511's here now, so this button technically should be roughly where the I was going to say where the LED turns on. Oh, there we go, that one is. So we've moved one apart, so that one's doing the easy and that one's doing that one. So as you can see, it's really easy, and you can add as many buttons as you like. You just keep going. Same. Make sure these are similar resistance. It just keeps everything nice and clean for you, so you've got a rough idea. Plus, if it's if you want to map it, if the values are too high and too far spread, you can actually map the values within a range, which would make your life a little bit easier as well. But that's basically it. The code's obviously easier. The wiring's easy, it's just 3 wires. You got your power, your ground, and your signal, which is going to there, and that's all you have to use. And you can, like I say, you can go as many buttons as you like with this. Just keep going. Obviously there is a limit. You can't do any more than 1042, is it? I can't remember what the resolution is now on a 8-bit. 10, is it 1082? I can't remember. So yeah, you are limited in that fact, and plus you'll get a lot of interference from others. But if you go with the 1Ks, and obviously you can up the ground one, which should bring your resolution up higher every time. So very easy, really. I hope that helps. There's no other easier way I could describe it all for you. To me, that is super simple. So yeah, if you like that, leave a comment, or if you're not unsure, just let me know, or you know. But anyway, hope that helped, and thanks for watching.